name is Pankaj Sinsinwar. Welcome to my channel, Maths with Pankaj sir. This is part 2 of PYQs of circular measure. We will be starting with question 7. And my suggestion to you is you read the question first and then try to understand the steps to be followed and then go for the solution. So the question is, we have a diagram. It shows a metal plate ABC in which the sides are a straight line AB and arc AC and BC. The line AB has length 6 centimeter. So AB has length 6 centimeter. The arc AC is part of a circle with center B in radius 6 centimeter. The arc BC is part of a circle with center A and radius 6 centimeter. Find the perimeter of the plate, giving your answer in terms of pi. So the perimeter is combination of arc length of BC plus arc length of AC and length of AB. So perimeter total perimeter is always is equal to arc length AC plus arc length BC plus length of AB. Arc length is always given by r theta. So for both the arcs AB, AC and BC, radius is 6 centimeter. So using r theta, we have 6 into theta. So do we have any value of theta here? Not given. Okay. So we will have to solve this question using symmetricity. Okay, not like this. Okay, so for AC, for arc AC, first of all, I will have to draw the sector first. So we have to find this angle. Let's say it is theta. So we will join A and C as well. So we know that length of BC is equal to length of AB. Both act as radius, and also AB is equal to AC. This is also 6 centimeter. So triangle ABC is equilateral triangle with each angle equal to 60 degree, which is pi by 3 radians. So our angle is pi by 3. So I will multiply this by pi by 3 plus, again for BC as well, we have 6 into pi by 3, and length is 6 centimeters for AB. So we have total perimeter equal to this. So on simplifying, we get this value gives us 6 pi by 3. 6 pi by 3 is nothing but 2 pi plus 2 pi plus 6 centimeters, which is 6 plus 4 pi centimeter, and this is our final answer. Let's move to the next part of this question. Part B, read the question first. Find the area of the plate, giving your answer in terms of pi and root 3. So let me draw the diagram first. We have AB and we have two arcs AC and BC. Now we have to find area of this plate. So to find area, let me join AC. So now the area of the plate becomes summation of area of sector ABC. This implies area plate is area of sector ABC plus area of segment. Now area of sector ABC is half r square theta. Half radius is again 6 centimeter. So half r square theta. Theta is again pi by 3. And area of the segment. Area of segment is area of sector minus, you can take any of the sector, area of both the sector ABC and BCA, whatever you say, both are same. So area of the sector minus area of triangle. If you have to find area of the segment, see, let me draw a diagram again. If you want to find area of this segment, then first you will find area of first first you will find area of the whole sector, and then you will subtract area of the triangle, area of triangle this ABC. First you will find area of triangle ABC, and then you will subtract area of triangle ABC. Here also I can say ABC, which is 6 pi plus area of sector is half r square theta, which is 6 pi again, and minus area of triangle, which is half r square, half xy sin theta. Using area of triangle as half xy sin theta, so I will take xy as r square, which will be 6 square again, and sin theta, theta is again pi by 3, 60. So sin 60 is root 3 by 2, which becomes 6 pi plus 6 pi minus 36 upon 2 is 18. 18 into root 3 by 2, which gives us 12 pi minus 9 root 3 centimeter square. And this is our final answer. Let's move to the next question. Read question number 8. In the diagram, lengths of AB and AC are given 15 centimeter. Point P is foot of the perpendicular from C to AB. Length CP is 9 centimeter. An arc of a circle with center B passes through C and meets AB at Q. Show that the angle ABC is 1.25 radians. Angle ABC, which means you have to find this angle. Fine. We know triangle ACP. This is a right angle triangle. So by using Pythagoras theorem, we can find length of AP. By using Pythagoras theorem, we can find length of AP, which will be root of 15 square minus 9 square, 12 centimeter. Now, we know AB is 15 centimeter, therefore PB will be 15 minus 12 centimeters, which is 3 centimeters. Also, we know triangle CP and B is also right angle triangle. Therefore, 10 of B is equal to 9 upon 3, which is 3. This implies angle B equals to tan inverse 3, which is 1.25 radians. This is my final answer. Let's move to the next part. Read part B. Calculate the area of the shaded region, which is bounded by arc CQ and lines CP and PQ. So this is our shaded area. So if I subtract area of this triangle, area of triangle BCP, if I subtract area of the triangle from area of the sector BCQ, if I subtract area of this triangle BCP from area of the sector BCQ, I will get the required shaded area. For the sector, I can calculate area of the triangle by half into base into height. Base is 3 centimeter, we have just calculated. Height is 9 centimeters. So no issues for area of triangle. But how we can calculate area of the sector, which is half r square theta? Theta we have already calculated, which is 1.25 radians, which is angle B. Now our objective is to find the radius, which is BC or BQ. How we can find the length of BC or BQ? So I can find length of BC from triangle BCP. I can find this length using Pythagoras theorem, and this will be our radius for the sector area. This is a BC equals to root of 9 square plus 3 square, and which is root 90 centimeters. So we have radius, we have angle as 1.25, and we have base as 3 centimeter, height as 9 centimeter. Now area of shaded region equals to area of sector. Which sector? Area of sector B, C and Q minus area of triangle BCP. I can find area of sector BCQ as half r square theta, and r is nothing but length BC, which we have already calculated. So root 90 square into theta, which is 1.25 radians, minus area of triangle BCP, which is half into base into height. So base is 3 and height is 9. So this is our shaded area in centimeter square, and on calculation it will give you value, which is 42.7 centimeter square. Let's move to the next question. Read question number 9. The diagram shows the circle with equation this, and tangent to the circle at P 5, 4. So P is given 5 and 4. Tangent to the circle at P meets the x-axis at A and y-axis at B. Find area of the triangle OAB. O is the origin. Okay, so this question is from coordinate geometry, but actually this is a cross-topic question from coordinate geometry as well as differentiation and various other some concepts of circular measure as well, like area. So first of all, we have to find area of triangle OAB, which is a right angle triangle. So by half into base into height, I can find area of this triangle, but I do not have base and height. So for that, I need to have coordinates of A and B. If somehow I can find equation of tangent BA or AB, then I can have the points A and B. So first I will find equation of the tangent. For equation of tangent, I need a point and the gradient of the tangent. For equation of tangent, I need a point which is already given, point on the tangent, which is 5, 4, and I need gradient of the tangent. For finding gradient of the tangent, there are two ways. Either I differentiate the equation of the circle, or I can compare it with the general equation of the curve and find center of the circle. So I will not differentiate here. I will go for the second method. I will find center of the circle. Second thing we need is gradient of the tangent. So I will find center of the circle, which is minus g minus f. Center. See, general equation of the circle is x square plus y square plus 2g f 2gx, x square plus y square plus 2gx plus 2fy plus c equals to 0, and center is always minus g and minus f. So clearly we can see center is 3 and minus 2. Now gradient of the radius is y2 minus y1 over x2 minus x1. Gradient of radius is 4 minus 2 divided by 5 minus 3. 6 upon 5 minus 3 is 2. So gradient of the radius is 3. Therefore, if this is center of the circle, which is 3 minus 2, then radius is always perpendicular to the tangent. Radius is perpendicular to tangent. Therefore, gradient of tangent will be m1 using m1 m2 minus 1. Gradient of tangent will be reciprocal of the gradient of radius and with the negative sign, which is minus 1 by 3. Now, equation of tangent will be y minus y1, which is 4, equals to m x minus x1, which is 5. So this is equation of the tangent. Substituting value of x and y for point C, point A and B lie on the tangent. So for A, we know y equals to 0. Substituting this y equals to 0 in equation of the tangent, and we get x coordinate of A to be, substituting y equals to 0, we get x, wait, y is 0 minus 4 equals to minus 1 by 3 x minus 5, which gives us x equals to 17 centimeters. And similarly, we will get value of y for x equals to 0. Similarly, for x equals to 0, we get value of y to be 17 by 3 centimeters. Now area of triangle is, now area of triangle is half into base into height, which is half into base is 17 into 17 by 3 centimeter square, which is equivalent to 289 divided by 6, which is our final answer. Let's move to the next part of this. Read part B of that question. Point Q and R also lie on the circle such that PQR is an equilateral triangle. Find the exact area of the triangle PQR. See, coordinates of P are given as 5, 4, and let's say this is center C, and the coordinates are 3, comma, minus 2. So from this I can find radius of the circle using distance formula. So radius using distance formula is root of y2 minus y1, x2 minus x1 square plus y2 minus y1 square. So 5 minus 3 plus 4 minus minus 2 square, which is root 40. Our objective is to find area of the triangle PQR. Triangle PQR is, this is RQ, and this is, okay, so this is the triangle whose area we have to find. And see, if we subtract area of all the 3 segments, this is segment 1, Similarly, this is segment 2, and this is segment 3. From area of the circle, then we can find area of triangle PQR. There is method 2 also. We can find area of triangle RCP using half into base into height, and we can calculate the height using SOHCAHTOA, using this angle theta. So for now we will be calculating area using area of triangle PQR equals to area of circle minus area of segments. So area of circle will be pi r square. Radius we have already calculated root 40, so r square will be 40 minus area of segment. Area of segment will be area of sector minus area of triangle, which is 40 pi minus 45 minus area of sector. So area of sector is half r square theta, half radius is root 40, so r square will be 40, and theta, look, this angle theta will be 2 pi by 3, so half r square theta. You can clearly understand from the geometry that these three triangles, triangle 1, 2 and 3, these three angles subtend 360 degree at the center, so the angle for each triangle will be 2 pi divided by 3 minus area of the triangle, which is half r square sine theta, so half into 40 into sine 2 pi by 3, which is 40 pi minus 220, and 40 pi by 3 minus half sine 2 pi by 3. Sine 2 pi by 3 is sine pi by 3, so root 3 by 2. You can calculate it by using calci, so this will become 10 root 3. 20 into root 3 by 2 will be 10 root 3. So final answer will be, okay, wait, this is area of just one segment. This is area of one segment, and we have to find area of three segments. So I will multiply it by 3. Here also I will multiply it by 3 and 3. So this will become 40 pi minus 40 pi minus minus plus, and 3 into 10 is 30 root 3 centimeter square. So this will cancel out, and now area of triangle PQR is 30 root 3 centimeter square, which is our final answer. Let's move to the next question. Read question number 10. In the diagram, x and y are points on the line AB. X and y are points on the line AB. Bx equals to 9 centimeter and AY equals to 11 centimeter. Arc BC is a part of a circle with center x. Arc BC is part of a circle with center x, and AC is a arc with circle with the center y. And okay, show that angle XYC is 0.9582 radians. Angle XYC C. So we have to find this angle. So in triangle XYC, we have YC. In triangle XYC, we have YC equals to radius. YC is radius of the arc AC. So this is 11 centimeters. Also, XC is also radius of the circle, which is having radius 9 centimeter. So this is 9 centimeters. Therefore, XC equals to 9 centimeter. So sine Y in triangle XYC will be perpendicular upon hypotenuse. So perpendicular is XC and hypotenuse is YC. So that will be 9 upon 11, and value of angle Y or XYC, Y equals to sine inverse 9 by 11, which is 0.9582 radians. This is our final answer. Let's move to the next part. Read part B, and in which we have to find the perimeter of ABC. So for that we have to find the length of AB. We have to find this arc BC and this arc length AC. So perimeter of ABC is AB plus arc length AC arc length BC. Now for AB is a for AB we need to find AX. AB is AX plus XB plus arc length AC, which is R into theta. So AC for AC radius is for arc AC radius is 11 centimeter. So R into theta. We don't even have theta. So let's say it is theta, and for arc length BC, it is again R theta. So for BC, R is 9 centimeters. So 9 into theta, which is 90 degree or pi by 2 radians. So 9 into pi by 2. XB, we know that length of XB is 9 centimeter. This is 9 centimeter. We have to find length of AX, and we have to find value of theta. AX is AY minus XY. And AY is 11 minus XY using triangle XYC. So 11 cos theta. Value of theta we already calculated in part 1, and that was 0.9582 radians. Theta was 0.9582 radians, which we already calculated in part 1. So using this value, we can calculate total perimeter is equal to 11 minus 11 cos 0.9582 plus xb, which is 9 centimeters, plus 11 into 0.9582. Substituting these values in the calculator, we get final perimeter as 38.4 centimeter, which is our final answer. Let's move to the next question. Read question 11. The diagram shows a sector AOB, which is part of a circle with center O. So center is O and radius is 6 centimeter. So this is radius 6 centimeter, and sector is OAB. Pause the video and read the question first, so you will understand by yourself. Angle AOB is 0.8 radians. The point C on OB is such that AC is perpendicular to OB. Okay. The arc CD is part of circle with center O. Fine. Where D lies on OA. Find area of the shaded region. See, area of shaded region can be calculated by area of triangle AOC minus area of sector COD. Now, to find area of triangle AOC, which is right angle triangle, we can use half into base into height. So half into base is OC, and height is AC. And the area of sector we use half r square theta. So our radius is OC square into half r square theta. So theta is 0.8 radians. So now our objective is to find value of OC and AC, and then we will substitute these values and find our answer. So for AC, in triangle AOC, sine 0.8 radian will be AC perpendicular upon hypotenuse, which is OA. See, OA is radius, so OA is equal to 6 centimeter, because this is radius of the sector AOB. So therefore AC becomes 6 into sine 0.8. And to find OC, we will again use cos of 0.8 equals to OC divided by AO, OA. Therefore OC equals to 6 into cos 0.8. Now substituting these values, we have area of the shaded region equals to half into OC 6 cos 0.8 and AC 6 sine 0.8 minus half OC square, which is a 6 cos 0.8 square into 0.8. So upon calculation, after calculation, we have this value as 2.01, which is our centimeter square, which is our final answer. Let's move to the next question. Read question number 12. In the diagram, ABC is a semicircle, which is clearly seen, and diameter is AC. Center O and radius 6 centimeter. The length of the arc AB is 15 centimeters. The point X lies on AC, and BX is perpendicular to AX. Find the perimeter of the shaded region BXC. You have to find perimeter of the shaded region, which is BX plus XC plus length of the arc BC. So I'll write this perimeter of shaded region equals to bx plus xc plus arc length bc. So we have to find all these lengths. Look, we are given arc length as 15 centimeter. So using this, 15 centimeter equals to r theta, which is 6 into theta. Let's say this is theta. So theta is 15 upon 6 radians. Now if we have to find angle BOX, for angle BOX we have pi minus 15 by 6 radians. So we have angle BOX. Also length of OB is 6 centimeters. So using triangle BOX, BX equals to 6 sine theta, which is pi minus 15 by 6, and OX equals to 6 cos pi minus 15 by 6. So you will get BX as 3.59 centimeter and OX as 4.807 centimeter. So now you can calculate perimeter of the shaded region as BX, which is 3.59 centimeter, plus XC is 6 minus OX, so 6 minus 4.807 centimeter, plus arc length BC, which is r theta. So radius is 6 into theta is pi minus 15 by 6. Therefore this length, the total perimeter will be 8.63 centimeter. This is our final answer. Read question 13. The diagram shows a cord going around a pulley and a pin. The pulley is modeled as a circle with center O and radius 5 centimeter. The thickness of the cord and the size of the pin be neglected. The pin is situated 13 centimeter vertically below O. Points A and B are on the circumference of the circle, such that AP and PB are tangents to the circle. The cord passes over the major arc AB of the circle and under the pin, such that the cord is taut. Calculate length of the cord. So we have to find length of AP plus length of BP plus length of major arc AB. So length of cord equals to AP plus BP plus arc length AB. Arc length AB, and this is major arc length, you can write. So AP and BP simply you can find using Pythagoras theorem. This is 5, this is 13. So AP is 12, which is under root of 13 minus AP equals to BP equals to under root of 13 square minus 5 square, which is 12 centimeter. So this is 12 centimeter plus 12 centimeter plus arc length AB. So arc length is r theta. We have radius equals to 5 centimeter, but we do not have this angle theta. but it can be written r is 5 centimeter r theta. So theta can be written as 2 pi, which is 360 degree, minus 2 into angle AOP. I can write it like this because AOP is equal to BOP. So therefore 2 into angle AOP, and if you subtract it from 360 degree, it will give you theta, which is 24 plus 5 into 2 pi minus 2 into C. This angle can be written as um, cos angle AOP will be base upon hypotenuse. So 5 upon hypotenuse is 13. Therefore angle AOP will be cos inverse 5 by 13, which is a 1.176 radians. So 2 into 1.176 radians, and we will get our final answer as 43.7 centimeter. Read question number 14. The coordinates of the points A and B are this respectively. Show that the equation of the perpendicular bisector. This is not from circular measure, so we are going to skip this question. Now read question number 15. The diagram shows a sector CAB, which is part of a circle with center C. So a circle with center O and radius r lies within the sector and touches it at DEF, where COD is a straight line and angle ACD is theta radians. Find CD in terms of r and sine theta. CD. Okay, so we know CD is CO plus OD, and using triangle C, this is 90 degree, angle CFO is 90 degree, so it is right angle triangle. So using, therefore, perpendicular upon hypotenuse, so sine theta is perpendicular, which is radius, and hypotenuse is OC or CO. Therefore OC equals to r upon sine theta. So r upon sine theta plus OD is also r. So we have, this is CD, which is radius of the sector. This is CD, and I will write it as radius of the sector. R upon sine theta plus r. This is our final answer. Let's move to the next question. It is now given that r is 4 and theta is pi by 6. Find the perimeter of the sector CAB in terms of pi. CAB perimeter. So perimeter is CA plus arc length AB plus length CB. So perimeter of the sector equals to AC plus BC plus arc length AB. AC plus BC are radius of AC and BC. So I can say AC equals to BC equals to radius of sector, which is r upon sine theta, which we calculated in the previous part, plus r. So using this in this question, 2 into radius of the sector, which is r upon sine theta plus r, and arc length AB is r theta. So our radius is r upon sin theta plus r, which is radius of the sector, and small r is radius of the circle, into theta. So theta is this angle, this complete angle. So this is twice of theta. Now substituting value of r and theta in this expression, we have 2, r is 4, so 4 upon sine pi by 6, which is 30 degree, plus 4, 4 upon sine 30 plus 4 into 2 theta. So theta is pi by 6, so which is equal to, I can say 4 upon sine 30 degree. Sine 30 is 1 by 2, which becomes 4 to the 8, 8 plus 4, 12 into 2, 24, plus 4 upon sine theta is 8 plus 4, 12, and 12 into 2, 24, 24 upon 6 is 4 pi. So this is our final answer in centimeters. So yes, this is final answer. Let's move to the next part. Part C. Find area of the shaded region in terms of pi and root 3. Area of the shaded region. So look, if we can find area of triangle COF, then by subtracting area of sector this from the area of the triangle, we can get area of this region. Let's say this is R1. So area of the shaded region will be 2 into area of R1. So I can write area of shaded region twice so now area of region R1 is area of region R1 is area of triangle. This is area of triangle minus area of sector. Okay, for triangle you can write OCF, and for sector you can write OF, and let's say this point is M, so OFM. Fine, but for that we need this angle, this theta. So how can we find this angle? We know that this is 90 degree, and theta is given to be pi by 6. So using triangle property, this angle becomes, this theta becomes 90 minus, or you can say pi by 2 minus, because we are finding in radians. So this is pi by 2 minus pi by 6, so which is basically pi by 3. So this angle is pi by 3. Now area of shaded region is 2 into area of triangle OCF is half into xy sin theta. X is radius, y is OC, and theta is pi by 3 minus area of sector, which is half r square sin half r square theta. So radius is 4 half r square. Let me write half r square theta, and theta is pi by 3. 2 into half, radius is 4. OC, we already calculated OC to be OC equals to r upon sin theta. R upon sin theta, which is 4 upon sin theta. Theta is pi by 6. into sine pi by 3 minus half into r square 4 square pi by 3. Finally, sine pi by 6, which is sine 30 is 1 by 2. So again, this becomes 4 to the 8, and this is 2. 8 to the 16. 16 sine pi by 3. 16 sine 60, which becomes 16 into 8 to the 16. Okay, 16 into sine pi by 3, which is root 3 by 2, minus 4 square is 16. 16 by 2 is 8. So 8 pi by 3, which is finally 16 root 3 minus 16 pi by 3. This is our final answer in centimeter square. Let's move to the next question. So this is question number 16. In the diagram, ABC is an isosceles triangle with the AB equals to BC equals to R centimeter, BAC equals to theta radians. The point D lies on AC, and ABD is a sector of circle with center A. Express the area of the shaded region in terms of R and theta. You have to find area of the shaded region. So see, this is R. So this is isosceles triangle, and this must be theta. And if we have to find area of the shaded region, then we have to subtract area of shaded region will be area of triangle ABC minus area of triangle, sorry, area of sector ABD. Area of triangle ABC will be half into R square sine of this angle, which is uh, pi minus 2 theta. Area of sector ABD. So area of sector is half R square theta, half R square. Area of this sector will be half R square theta, and this angle is also theta. So which is okay expression. So this is our final answer. Let's move to the next part of this question. In case where R is 10 and theta is 0.6, find the perimeter of the shaded region. So perimeter will be arc length BD plus CD plus BC. So arc length BD is R into theta, which is 10 into 0.6 centimeter, and CD is AC minus AD, and AC we can calculate using either sine rule or cosine rule. So using cosine rule, AC square equals to R square plus R square minus 2R into R cos pi minus 2 theta. So AC is under root of 2R square minus 2R square cos pi minus 2 theta. On substituting R equals to 10 and theta equals to 0.6, AC equals to 16.506 You can also calculate length of AC using this method. Let's say this is M and BM is perpendicular to AC. So I know AM is R cos theta, and this is also R cos theta. So AC is 2R cos theta. So I think this is easier one. AC equals to 2R cos theta, and substituting value of R and theta, you can find value of AC 16.506 centimeter. So here I have 16.506 minus AD. So AD is radius only. 10 equals to 6 point centimeters. Now BC. BC equals to R equals to 10 centimeters. Therefore, total perimeter is 10 into 0.6, which is 6 only. 6 plus the total is 16 plus 6, 22.506. So you can write simply 22.50, and that is your final answer. Let's move to the next question. Read question number 17. In the diagram, CXT is a semicircle of radius 7 cm with center A and diameter CD. The straight line YABX is perpendicular to CD, and the arc CYD is part of a circle with center B and the radius 8 cm. Find the total area of the region enclosed by the two arcs. Total area of the region enclosed by two arcs. So total region is combination of two. One is area of semicircle CXT, and other one is area of sector CYD. So area of the region enclosed by the two arcs is nothing but area of sector CYD plus area of semicircle CXT. Now area of sector is not sector, it is a segment. This is segment, not sector. This is segment CYD. So area of segment CYD is area of sector minus area of this sector. Let me connect this. Area of sector minus area of triangle. So area of sector minus area of this triangle. I have shaded area of the triangle. So area of sector C, B, D. Area of sector CBD minus area of triangle CBD. So area of sector CBD minus area of triangle CBD plus area of semicircle CXT, which is a area of sector CBD. For area of sector CBD, we have to find this angle. So for angle, we will take triangle C A B 90 degree. Let's say this is theta. So CA is 7 and this is 8. Now perpendicular upon hypotenuse, sine theta. Theta goes to sine inverse 7 by 8, which is equal to 1.0654 radian. this complete angle will be 2 theta. So this is 2 theta. Now area of sector CBD. CBD angle CBD is 2 theta. So area of sector will be half r square theta. So half r square, which is 8 square theta. So which is angle CBD. So angle CBD is 2 into theta, 1.0654 minus area of triangle CBD. So for triangle we will use half x by sine theta. So half into r square, which is 8 square again, and sine theta. Theta is again 2 into 1.0654 plus area of semicircle CXD. So this is quite easy. Area of semicircle is pi r square by 2. So pi, and radius is 7 upon 2. On calci, after substituting, you will get the total area between these two arcs is 118 centimeter square, and this is our final answer. Let's move to the next question. A sector of a circle of radius r centimeter has an area a centimeter square. Express the perimeter of the sector in terms of r and a. So this question is easy. A sector of circle of radius r has area a. So area of sector is half r square theta. Express perimeter of the sector. So let's say this is perimeter, this is sector, this is theta, and this is r. So area is half r square theta. And if you ask me what is perimeter, so perimeter is r plus r, which is 2r plus arc length, which is r theta. So now from perimeter you have to eliminate theta. So from equation 1 we have theta equals to, from equation 1 we have theta equals to 2a upon r square. So perimeter is 2 into r plus r into 2a upon r square. This cancels out. Now we have 2r plus 2a upon r centimeters, and this is our final answer. Question number 19. The diagram shows a semicircle with the diameter AB, center O and radius R. The point C lies on the circumference, and angle AOC equals to theta radians. The perimeter of sector BOC is twice the perimeter of sector AOC. So perimeter of BOC is twice the perimeter of AOC, and the value of theta. Now if this is theta, then this is pi minus theta. Therefore, now perimeter of AOC is 2r plus r theta. Perimeter of BOC will be 2r again plus r into pi minus theta. Now it is given that perimeter of BOC is twice the perimeter of AOC. So 2r plus r pi minus theta is twice of 2r plus r theta. This implies 2r plus r pi minus r theta equals to 4r plus 2r theta. Find the value of theta. So making theta as subject, now I have 3r theta equals to 4r, 2r minus 4r is minus 2r, and plus r pi. And if you eliminate r from left hand side and right hand sides, now you have theta equals to minus 2 plus pi divided by 3, which is 0.38. And this is our final answer. So this is we are done for today, and in the next lectures as well we will be continuing circular measures, and we will solve around 25 questions in total. So we have solved 19 questions already, and we will be solving like 6-7 questions in the next part, which will be our last part. So see you in the next video. Take care. Thank you so much.